All right, can we start? Yes. So good morning, everyone. Pretty happy to be here. I hope you got, a very good and sleepy night. Ready for all the thing. I had a very short night, so what I'm going to try and propose to Stefan is to dedicate one room between 3 and 4 for sleeping, right? No sound, no nothing, just sit and rest. I think that might be a good idea for next year. So we're going to talk about a specification that is a work in progress, and because I'm not a known, descendant of Nostradamus, I will not be able to guarantee for sure that everything that I'm going to talk about will be actually present in the specification. But at least you know that is the goal of the expert group, to actually bring all of this into Bean validation for the next revision. And what I will do today is to remind you what Bean validation is, so you get the key concept that we will expand on Bean validation 1, so you understand what's going on. The second thing is, then I will move to Bean validation 1.1. What are the new features? And for those features, I'll tell you why it matters to you, in your future applications. So my name is Emmanuel Bernard. I'm working for JBoss. I'm a data dude. So everything related to data, so Hibernate, InfiniSpan, ModShape, all those projects, I try to coordinate a bit the vision of all of these projects to bring forward the ideas we have in mind. But I'm a coder at heart. So my latest baby is Hibernate OGM, which is trying to use Hibernate but to store data into NoSQL stores and not relational stores. We already have, quite a few success, so, have a look at it. It's definitely still a work in progress, but that's interesting. Also working on Hibernate Search, Hibernate Validator, which is the implementation of Bean validation, and on Ceylon. Ceylon being a modern language that would, what would be Java if we were designing it today and learning all that we have been thinking about in the last 17 years. And more than that, what would be the actual SDK if we were designing it today? I'm also, a participant in various specifications, most notably the JPA expert group, and of course as a spec lead of Bean validation. And I do a couple of podcasts, so if you, like the sound of my voice, you can have a look at asylum.jboss.org. It's all about JBoss community projects. We do a podcast every 3 months, so it's not going to be a high burden for you. And if you understand French, you should go to Les Cascodeurs, which is kind of a French version of the Java Posse. And we actually do a recording Friday morning at 10:45, so come and see us. All right, so what is Bean validation 1.0? And why did we do that? Well, if you looked at the Java ecosystem before Bean validation, we had different layers. And for a lot of those layers, we were actually having some kind of validation logic attached to them, except there was no communication between all those layers. So, in Hibernate, you could define some constraints that would be propagated to the database. At the business layer, you can actually verify that the parameters provided as input are valid or not, right? Of course, at the presentation layer, you want to provide feedback to your user. This phone number looks incorrect. Your email address looks fishy, so can you try and fix it, right? Unfortunately, the thing is that the constraints are actually more or less the same across the different layers, except that you had to define them at all of those layers to make them work. And worse than that, the implementation's been somewhat different. You might let one incorrect data pass one layer and then fail at the other layer. So you would have some kind of inconsistencies here. And even beyond Java, even beyond your Java web frameworks, generally speaking, you want to push the constraint either on the client side or at the database level to be able to share the same constraint across applications, for example, and of course to get a very fast feedback for your client. So the idea was to say, how about we go with a standard express the constraints in your domain model and let all of the frameworks reuse these constraints that you define on your domain model and validate them with the same logic, same semantic, right? So that was the idea. But to actually push this idea, you also have to have some nice integration with the various frameworks. So we have started with the JavaE specification. So for example, in JPA, every time you save an entity or update an entity, we actually do validate the entity to make sure it's valid before going to your database. Every time you push some data from a form into a bean via JSF, well, the bean being annotated with a few constraints, we check those constraints to make sure that the user has provided valid data. Otherwise, we bring back the error to the user saying, you know what, this field doesn't look right. Looks like your email is missing an at or something like that. And we also made the bean validation service available as at the JavaE platform, especially via CDI, just by injecting validator or validator factories. But that goes beyond that. That was kind of the kind of super example that other people should follow. And that's what happened. Other technologies beyond the JavaE ecosystem actually integrated with bean validation. And that's exactly the goal. GWT has an integration, Wicked, Tapestry, a lot of different web frameworks actually have done the same kind of integration we did for JSF. Spring did the same kind of integration that CDI did, and even a bit more actually. I don't know about persistence technology, but there might be some out there. So how do I actually declare constraints on my domain model? Well, it's very easy. You just use annotations to express on a property that there are some additional constraints. It's not just a free property. You put some constraints on it. So if we look at address here, the street one must be of 50 characters maximum because, let's say, my database doesn't support more, and it must never be null. Otherwise, I won't be able to ship the package to my customer. Not null and size are actually default constraints that are built into bean validation, but you can write your own constraints. So let's say you, in your country, you know exactly how to validate zip code. You can actually write a zip code constraint and attach a validator to it and use this zip code constraint in your domain model. So we really encourage you to write your own constraints. For example, I know in Brazil they have created an open source project to validate the various healthcare styles, social security number validation across all Brazil. So a Brazilian developer can just reuse this constraint and validate it. You can also not only validate an object and all the properties of this object, but also associated objects. So you validate really the object graph. So in this case, when I validate an address, the country is also validated. Why? Because we have add valid annotation on it, so we literally cascade the validation to it. Sometimes you want to validate not one property, but several properties. Let's say, I'm international, so I want to validate both the zip code, but depending on the country, the validation of the zip code is a bit different. So what you do is you put the constraint on the class itself, and what you receive is the address object, and of course you can do address object.getZipCode and then getCountry to actually do the validation logic. Okay. Another feature we had introduced in version 1 is the notion of group, and the notion of group lets you. So by default, constraints are in what we call the default group, and when you validate an object, we validate all the constraints in the default group. But what if some of the constraints must be validated in one case, but not in another? Groups are here to let you define subgroups of constraints you want to validate at a given time. What would you want to do that? One use case is partial validation, so you have received some of the data, but not all of it. So if you put that in your object graph, the object graph itself will not be valid, but you want to validate at least the part that you have received. So you can put the constraint on the data that you have received and put them in a specific group and validate this group. The second interesting use case is to validate that the object or object graph is in a given state. So it's not so much validation, but making sure that the object graph is in state 1 versus state 2. Let me give you my canonical example. I'm Amazon, and I've got a buy-in one-click button. What I want to make sure is I will display this buy-in one-click button, but only if the user has a default credit card, default shipping address, default billing address. Otherwise, I cannot display it, right? So you can literally say, is this user buy-in one-clickable? Well, not exactly, but you get the point. You basically use a group buy-in one-click, and you put the annotate the associate this group with the constraints. And how do you do that? There is a group property on the constraint annotations, and you can put more one or more groups on it. By the way, a group is an interface. It's not a string because we want it to be type safe. So if you make a typo, the compiler will tell you. The other thing is that we can actually inherit one group over another. So if I subclass a group, I will validate all the constraints belonging to this group and all the constraints belonging to the super class, or the super interface, sorry. So address has a basic validation and some advanced validation, the code checker here. If I only want to validate the basic constraints, what I do is I use the validator and call validate on the object and pass the actual group I want to execute. Make sense? So I told you we encourage you to write a constraint. So how hard is it to write a constraint? Not too hard. Actually, not hard at all. The hardest part is to find the best name for your constraint so that it's very readable when you use it in your domain model. So in our case, it's just an annotation, in this case zip code. We have 3 mandatory properties: message, groups, and payload. You have to put them that way, and of course you can add additional properties that are specific to your constraint. In our case, the country might be interesting, right? But the key thing is that this annotation is annotated with a constraint annotation, and that really tells Bean validation, you know what? When there is the @zipcode constraint on the property, go and run the string zipcode validator class. Okay? And string zipcode validator class is an interface, an implementation of an interface that first of all says, you know what, I'm validating zip codes, and B, I'm validating properties of type string. So you can actually stack more than one validator, one for string, one for numbers, and Bean validation will actually choose the right one depending on the return type of your property. But how do I implement it? That's very easy. There is 2 methods. One is initialize, that gives you the actual zip code annotation, so you can extract the country in this case and some additional settings. And the second one, the most important, is valid. You get the value and you say, yes, it's valid, or no, it's not valid. All the rest is actually handled by the Bean validation framework. All right, so that was the kind of memory refresh for you guys. Actually, who did not know about Bean validation? Well, that's good. Perfect. 100% success. Woo. So let's talk about Bean validation 1.1. Why is it 1.1 and not 2.0? Well, we're not like Google and Google Chrome, so we don't try to push stuff that far apart. And it's really an evolution. So we've been a bit conservative with Bean validation 1.0. A, that was our first spec, and B, we wanted to say, let's do less, and if we need to add stuff later, that's much easier than deprecating things. So what we have added here is a few properties, but let's talk about the meta feature of Bean validation. Bean validation is actually truly open. We already came from open source roots. Hibernate Validator is the reference implementation of it. But for Bean validation 1.1, we pushed the stuff to the much further. So first of all, we have a website where we publish what's going on. So there is like a blog with news. There is, actually I can show it to you. So, it's a very simple website. It explains what Bean validation is. You can actually access the spec, read it as HTML. You got the latest snapshot if you want to. Go read it. We actually have changes. Additions are in green. Updates are in yellow, and removals are in red. I don't think we removed much But so that's, you can access the latest version. You can see our roadmap. We have actually a list of stuff we want to do by priority, list of proposals, so stuff we've been already working on and have kind of a half-baked solution. And then when it's green here, that means it's in the spec, and that's going to be in Bean Validation 1.1. And of course, if you want to contribute, and I don't think you have a choice, you have to contribute. So go here, go to beanvalidation.org/contribute, and follow what's going on here. You can go to the mailing list, have a look at what we're doing, propose changes, help on the Jira, anything, right? And everything we do is actually in the open. So the spec is in GitHub, the RI is on GitHub, the TCK is on GitHub, the website is on GitHub. So if you find my typos, please go and fix them and send a pull request. I think I'm the first 100% fork me on GitHub specification. I hope many others will follow, by the way. That's a great way for us to streamline the evolution and get everything in the open. For example, the proposals that are displayed on the website really show the progress we made while thinking about the feature. Like, we had those options, decided not to do that for that reason, and so on. So we can come back in time and say, the reason why we didn't do that was for that, instead of having to ask the expert lead that says, I kind of remember there was something wrong, but I don't, quite get the details. Everything will be here for posterity. So please go contribute. If Bean Validation 1.1 sucks, well, that's your fault. So, you get the gist. So let's talk about actual features. The first big one we did is a much deeper integration with the container frameworks, and especially dependency injection frameworks. So Bean Validation has a few components that it manages the life cycles to. And the idea was to say, how about we delegate this life cycle to the actual dependency injection framework so that you could use all the goodies of your dependency injection framework and inject other beans and use that. We could have done it just for CDI, but what we did instead is think about the dependency injection problem in general and offer the actual extension to have a nice integration between CDI and Bean Validation. But that also means that other dependency injection frameworks like Spring or Juice actually can do the same thing and integrate Bean Validation the same way. So what can you use dependency injection for within the Bean Validation ecosystem? Well, the most important one is Constraint Validator implementations. So that's, remember the string zip code validator I was talking about? What if you want to inject a service that lets you, access a web service to actually check the zip code, right? That's the use case we really had in mind. But we pushed it to even other components we have, like message interpolator, traversable resolver, and constraint validator factories, so that any one of them is actually a CDI bean or a Spring bean or whatever, and you can actually use them. So here is an example. That's an example we used before, but I've used a service here. I use a zip code checker for the US, injecting it, and in isValid, I'm actually using it. That makes sense, right? It looks natural, but that's an interesting thing about a spec. You try to make it look like, duh, of course you need to do that. But the hard work is to make it simple for you and actually work spec-wise. So I have a question for you. Actually, I have a couple of questions for you, but one of them is, how far should we go about integrating a dependency injection framework and Bean Validation? For example, the default, the way you customize other components like message interpolators is by using an XML and describing, here is the default implementation I want to use, or by using the programmatic API for it. But we were wondering if, for example, in CDI, we should provide some kind of, how do you call that? A qualifier that says, you know what, the default I want to use out of the box is not the actual default message interpolator, but my implementation here. And I can actually build it as a CDI bin. So I don't know if that's useful. So far, it's not in the spec. So please come back to me after the talk, and let's have a chat about your feeling about it. Look like a psychiatrist, Tell me about what you want. The second biggest feature that took us a long time to to refine, and we're still improving it right now, is method validation. So at very specific life cycles like JPA save, JSF, or even when you explicitly call validate, we actually validate a bin. So you pass the bin you want to validate, and we go and validate it. That's bin validation 1.0. But if you think about it at the business layer, it makes a lot of sense to say, you know what, the parameters coming in should be valid, and potentially the return value coming out should be valid as well. So how can I do that? Well, initially, in bin validation 1.0, you had to actually call bin validation manually, right? The solution here for bin validation 1.1 is simply to intercept your call to the method. So, for example, you're calling a given service. Instead of calling the actual method implementation, bin validation interceptor is right in the middle. So you call you're the client, you call the method. The bin validation interceptor look at your parameters, validate them. If they are valid, that's good. We go and execute the method operations. The method goes on, potentially returns a value. When we look at the return value, we try to validate it. And if it's not valid, we raise an exception. If it's valid, we give that back to the client. So if your data is valid, it's transparent for the client. If it's not valid, what happens is that we get the list of errors, and we put that in a constraint violation exception, and we raise the exception to the client. Okay? So think about it as a round invoke interceptor. That's exactly what it is actually. That actually validate your parameters, then delegate the method call, then validate the return value, and then come back. Make sense? So how do we do interception? So no, we don't implement some kind of interception technology in bin validation. What we do is provide actually specify the logic that an interceptor should do, and it requires some interception technology. So the one in Java EE is either CDI or managed bin interceptors, and we will provide a built-in support for CDI and very likely managed bin interceptors as well. But of course, Spring can provide its own interceptor logic as well, and any AOP framework, let's say AspectJ or anything like that, can do that too. So that means that we can intercept all the methods that the interceptor technology can intercept. So CDI and the default Spring interception technology is based on proxies. So that means that as a client calling a given object, we can literally intercept this call, but once inside the object, we cannot intercept a method call, right? So that's one of the limitations of this kind of interception technology. So that means that bin validation will be able to validate when the interceptor can be applied and not if it's not, right? If you use AspectJ, which can do just fancy bytecode thingy, then of course you will be able to validate just about anything. We're trying to hammer that out so that the rules are clear and easy for you to understand. That's a bit of a challenge for this one. So I talked about method interceptors, but it's actually about method and constructor interceptors, right? So you can also put constraints on your constructor, for example. So why do you want actual method interceptors? I see a few use cases. The one we had in mind when we worked on the first version of this feature is validating the business input and the business output, right? So you as a service provider say, you know what, the parameter should be not null, this should be an email. If it's not, I'm sorry, but I cannot do anything about it. So I will put the constraints on those validators, and the client can actually look at it and say, well, these are the list of constraints I need to be sure my parameters use. And instead of you having to code manually in your business, in your service, the validation, you just simply declaratively express that, and the bin validation and the interceptor technology framework will do the job for you. So that means that your code, your method code is even less polluted than it used to be before. So your method code is all about the actual business logic, and the validation logic is actually pushed away. And you can think of it as a programming by contract. So the idea of saying, this method expects that and will return that, you can count on it, or you get an exception. So it's sort of like Javadoc, but useful, right? Because if you put it in a Javadoc, please never, ever, ever pass a null object to this method, what happens? Well, of course, the NPE, because the guy didn't read the Java doc, and then complains. So here that would be actually enforced, and instead of having a vague NPE somewhere, you will have a very useful message saying, I'm sorry, but this is not valid for calling my method. So that's how you would do it the old way. So you got a service. I'm calling the service.createUser. And createUser really wants to validate a few things. The username should not be null. The email should be an actual valid email. So the old way to do that is to actually literally do the validation yourself in your code and throw some kind of exception if it's not the case. It's kind of annoying, a bit verbose, and when you start working on a method, what you really want to work on is the actual business logic, not the validation. It's just boring. Well, it's boring for you, not for me, because it's sort of my job. So the new way to do that is just use actual Bean validation annotations, right? Just the way you would annotate getters, here you annotate parameters, and you're good to go. And we anticipated that for Bean validation 1.0, so we really encourage all the constraint provider to also support parameters. You know, an annotation can be put on a type, a method, a constructor, a parameter, and you have to define that when you define the annotation. So we encourage people to do the right thing here. So compare that code, which is imperative, to that code, which is more declarative, and expressing this username is not empty, and then carry on it. Okay? Remember, there is validation done right before you actually enter this code, and when you return the value user in this case, you potentially validate the user, right? That's what the Bean validation will be doing. So you can validate simple parameters, strings, you know, URLs, whatever you want. But you can also validate full object graphs. Remember the add valid annotation to validate an object graph. So you validate an object, and upon an association, you go and validate the associated object. That's the same semantic here. I want A, the user to be not null, and B, to be valid. So I use the add valid annotation here, and all the constraints on user will be validated. Make sense? If you know Bean validation, that sounds sort of like boring because you already know all the logic here. And you can validate return values. So to validate return values, you just put the constraints on the method itself, because just like a getter which returns a given value, you have a method returning the value. Good? So there's a few things to remember. It works as good as your interception technology, so we don't do magic. We're not in the business of re-implementing AOP framework. Rather, we want to integrate with them. The other thing interesting is of course, Java is an object-oriented language, but I guess you know that. So that means we try and respect the fundamental logic of object-oriented programming, including the Liskov substitution principle. What does that mean? That means that if a class has a given set of constraints for a method being called, I cannot put more constraint on the parameters for any subclasses, because if I substitute the subclass with the class, and if the subclass happens to have more constraint on the parameters, well, I'm cheating because the guy didn't know about those additional constraints. He thought about the superclass as the constraint definer. On the other hand, on any of the return value, you can put additional constraints, because the return value is, from a client point of view, is the guarantee. You're guaranteed this stuff to be not null. If it happens to be an actual valid email, great, awesome. But that's not what I knew of before, right? So you cannot refine parameter constraints when you override a method. You can refine return value constraints if you want to. I have a question for you. So remember, Bean validation was about validating beans and properties, and now we are going into validating methods. So the big fundamental question is, because Java sort of screwed up, not screwed up, but we could have known better back in the days, but fundamentally we should have had native property support in Java, but we don't. We have kind of a pattern that says this method actually, because it looks like that, is a getter and not a regular method. So the question is, should we consider getters as method or not? I've listed the pros and cons. So far in the expert group, I'm on the getters should not be considered methods, and all the other the rest of the expert group is yes, getters should be considered methods. So I need some help. No, more seriously, if you have some opinions here, I'm really interested into knowing that. The pros for getters being considered method, it's just, it makes sense, right? A getter is a method, so why not? Also, some get something methods are actually action methods, so you might want to validate them. And in practice, Hibernate Validator had that feature as a proprietary extension for a while, and it has never been a problem. But me as a spec lead, I'm a bit concerned about that because all of a sudden, all the constraints you've put on the getters today for Bean Validation 1.0 might actually trigger a method validation, and that might actually make your application fail where it should not have. So I'm really concerned about that. And also, depending on how advanced we're going to push the interception technology, we might happen to validate getters much more than possible. So, for example, who is for the idea of considering getters actual methods and validate them? Okay, about a tenth. Who thinks about the opposite, so not validate them? Wow, big majority. Good, so you're with me. I'm good at convincing, I guess. Who doesn't care? All right, some people. So we might try, one default, another default, plus options. We're really shuffling here. So if you have ideas, please come and talk to the expert group. So just send us an email, really. Another feature I want to talk about is group conversion. Group conversion is it's a tiny little feature, but that's quite useful for reducing the kind of hover rate of using groups inside an object graph. It's kind of a NAT technology for constraints, so that's an interesting thing. The idea is to say, you know what, when I'm on object 1 and I'm validating the group A, I've got an association between object 1 and object B, and I put an add valid annotation on it. But object B doesn't really know about group A. It knows about group B, and that's really this kind of same representation. But I don't want to ask the user to validate group A and B because I'm using this object graph. I just want to hide that underneath the big group A. So how do I do that? I can actually define a conversion when you cross the bridge between object 1 and object 2 to do the validation. You switch from group A to group B, do the validation with group B, come back, and then continue on group A for validating the rest of object 1. Okay? And it's really to facilitate object graph reuse and constraint reuse on object graph. Here is an example. I've got a user which has to have a valid address, except that address is kind of fine-grained. You can validate just the basic of the address or a more complete part of the address. Okay? If I try to validate it in Bean Validation 1, I have to do please validate user with the default group and the, let's say, basic postal group. With group conversion, you do that. You say, you know what, when you're validating default group and crossing home address, go and validate the basic postal group. And if you validate the complete group, go and validate the full postal group. Another sort of meta feature of Bean validation is to try and improve integration between Bean validation and other specifications, and of course Bean validation and other frameworks, right? So it's kind of it adds 0 line on the specification, but it takes us a lot of time. One thing we did is working hard with the JAX-RS leads and expert group to have a very nice integration with JAX-RS. So JAX-RS is kind of an entry point between the rest of the world and the Java world via a REST endpoint, right? And everywhere there is some kind of endpoint between Java and, between one system and another, it makes sense to actually have some validation. So there are more than just JAX-RS as an endpoint in Java, but we had to start somewhere, so this is the one we've done. And what you can do is, for a JAX-RS resource, just literally annotate put the constraints on these resources and literally validate the various HTTP elements you have bound to your object. You will it will look very much like method validation. That's because we literally build method validation with JAX-RS in mind and then made it more generic. And another awesome thing, well, at least I find it awesome, is that JAX-RS is about REST services and the web and HTTP, right? An exception doesn't make sense. What makes sense is HTTP error codes. If you think about somebody calling a method with the wrong type of parameters, that's an error from the client side. It should not have called it that way because that's wrong. That's an HTTP 400 something code, right? So when parameter validation is failing, JAX-RS actually integrates with bin validation and raise HTTP 400 code as a return type for the return error code for the resource. On the other hand, if the return type is not valid, it fails. But that's a different kind of failure. It's not that the client made something wrong, it's that the server made something wrong. So we raise an HTTP 500 error. So this kind of mapping makes it very nice and natural to bind REST errors and the Java errors in bin validations. By the way, return type validation is probably much less popular and has less use case than parameter validations. But it might just be because it's an ego problem. Yes, I don't trust my clients to provide me the right parameters, so I'm going to validate them. But my code is awesome, no bug. So I'm not validating my return value. So keep that in mind and try and put the constraints on the return value anyways, even if you think your code is just awesome. Why? Even if you're right, the thing is that the constraints will be visible in the code, so when the guy navigates and looks at your interface, for example, it will see the contract that you've defined. So it will be able to say, oh yeah, that's never null, so I'm not going to check for null, for example. Okay? So how do you do that in JAX-RS? Here I've got a method that is bound to a post, and I'm just calling register, binding a few form parameters, and adding the constraints on the form parameter. Looks like method validation, that's okay, that's method validation. By the way, you can also bind HTTP elements to getters and fields in JAX-RS, and you can also put the constraint there. Right? Not only can you validate simple HTTP types, but also the entity bodies that are actually bound to an actual Java object. Okay, so you can do add valid and validate the item object that probably was serialized as a JSON structure or something else up there. Let's talk about a few other quick things we're adding. I'm not saying it's the only ones, but that's the one I wanted to highlight. A lot of the built-in constraints support string validations. Let's say, well, of course, at not null, of course, size, and so on. But some people wanted to use them on string buffers and stuff like that. So we, instead of just validating strings, we actually re-implemented the validator and now support char sequences. Right, so you can actually validate a string buffer or a string builder. We plan on adding value interpolation in error messages. Error messages have interpolations, you can do that. You can especially include the parameter values of your annotations. Let's say size equals max equals 50. You can say your email should be lower than 50 characters, right? We can do that already, but what we cannot do is give you the wrong value. We were a bit hesitant because just calling toString on a random object is not necessarily doing the right thing. But if for people that are really interested in doing that and actually implementing their toString operations, we're going to support that. We also are going to add exclude flags on min decimal and max decimal to exclude the limits. And we're thinking about finding a way to make writing constraint validations easier. One of the issues is that for most constraints, you should ignore null values. If the value is null, return true, because if you look at a string email, right, and you say it's at email, it means it could be null or it has to be an email, right? That's the valid thing. If you want it to be not null and an email, you just put at not null and at email. So most of the constraints literally accept not null. just do if this stuff is not null, then return true, otherwise do my actual validation. And we're trying to think of a way to make it in a declarative way. So you just put an annotation or some kind of default ways to do that, so you don't have to write this thing that some people miss. All right, that's what I had in mind. I mean, that's what I had in in my bag for Bean validation 1.1. When is it coming? I've got a few dates here. The one in the past are correct for sure. The one in the future are probably correct. What's going on is we've released a public review draft, which is kind of a major milestone in the life cycle of a JCP JSR. So it's getting voted at the end of November. So if some expert group member or some people have some concern, we can talk about that, and we have to address that. Otherwise, we plan to propose a final draft around mid to end February, so that the spec will be released around mid-March, and other specifications will be able to integrate with it, like JAX-RS or Java E7, generally speaking. Right, so that's why we try to release a bit earlier than maybe some other specifications. We will very likely gonna push other versions, but just outside the JCP. On the website, we're gonna push various additional milestones. Can you use, this Bean validation 1.1 today? Well, sort of. We already have a alpha 1 version of Hibernate Validator, so don't be scared by the alpha tag. It's actually quite solid. We just added new stuff, but because the API will change or has been changed between the Bean validation various drafts, we put it as alpha. But it's implementing the previous draft. The latest draft, the public review draft I was talking about, is actually, we plan to implement it by the end of the month. So wait a little bit, and then you'll be able to start and use these. If you want to help, yeah, you're more than welcome. Go to the website again. So go to beanvalidation.org. You should have all the pointers to get more information or more feedback. Come participate. That's really useful. And on a side note, there's been a schedule. So Gavin King is going to talk about Ceylon and show you how to code in Ceylon entirely in the Eclipse IDE. So I think it will have no slide or very few slides. It's in this room at 2 p.m., so have a look. And if you're tired of technical things and just want to laugh a little bit, Manik is actually doing a quickie in room 4 at 1:10. Just by the title, you can sort of guess what might happen here. So it's kind of a chit-chat between two people of JBoss. It should be relaxing. All right, so we got plenty of time for questions, so go and shoot. Yes? Yes? So the question that will please Antonio is, so you said that you have integrated with JAX-RS. Why not with JAX-B and JAX-WS? Well, there's a finite amount of time that we can spend, but and the other reason is there is no revision of JAX-WS for this rev of Java E, so that would have made it a bit harder. We're going to try to sneak something in, but I cannot guarantee that will work. But our goal eventually is to actually do this thing. And for JAX-B, it's actually the same spec lead that is actually doing JSON-P, so it's busy on other stuff, unfortunately. But we have exchanged ideas, and I think we can streamline a specification integration to push the constraint on the schema of JAX-B and vice versa. We have the solution for it. We really need to push it out. Another question? Yes?
When you validate the JAX-RS service, you return a status code, for example, 400 or something. But do you also return like information in JSON format, like what fields were in error?
The question is when you have an error and validating a JAX-RS endpoint, you return the status code, but do you return more information, like exactly which parameter is failing? That's the plan. I'm not entirely sure if the JAX-RS spec mandates the structures, but the plan is to actually have the body of the of the HTTP response to actually contain the list of errors so you can go and navigate that. That might be specific of your implementation, let's say REST easy versus Jersey. It's a good question. I'll try to talk with the spec leads here. Another question, maybe in the back? No? Yes, go ahead.
What is the integration with JPA? You know, at not null and at column null.
Okay. So the question is, what is the integration with JPA at the database schema generation level, at not null and column not null and so on? I did propose something back in the day for bin validation 1.0, but because the schema generation was not standard, Linda was a bit cold feet on this one, so decided not to put it in. But that's a great reminder for me. I need to talk again to Linda, since we're planning on standardizing that, to try and push the generation and the binding between bin validation not null and the fact that the column should not be null. Another question? Yes?
Are you planning to take this out of the enterprise space and also standard?
The question is, are you planning to make it SE kind of a spec and not just EE? Well, first of all, it is, because bin validation is a standalone JSR, so you can literally take Hibernate Validator and the javax.validation jar and run in Java SE. No problem with that. Is it going to be in the JDK? That's an open question. I've been discussing with the JavaFX guy because they are in need for a validation framework. I would love to, we would love to actually get it in, but get it in the JDK is something more complex than just that. So we will see. But that's definitely where we want to go. The JavaFX team is actually very busy. So that's a bit of a problem here. But one of my team members is actually working on an implementation, like a prototype, and then we'll come back to them and see if we can push that further. But that's the general idea. I'm not sure it will work, but that's what we want to do.
And the thing with JavaFX that I'm up here, it's Peter Pilgrim. And how would that work with context and dependency injections?
What do you mean?
Bean Validator is one of those specifications that is either or. It works with CDI and not CDI.
Yes.
So then, are you then, by that definition, going to push CDI to be standard in the JDK, or should it be better?
No, well, there is no compile time adherence between bin validation and CDI. And frankly, if we try and push CDI and bin validation in Java SE, I don't know. We're going to be dead 1 year from now. So I don't see it as being practical. But there is optional tie between CDI and bin validation. So if we, basically, if CDI actually bootstrap bin validation, we've got all those goodies. But if it's not, then you bootstrap bin validation out of the box and things work and you don't have to have CDI. And I think JavaFX in this example would actually bootstrap bin validation itself and use it. Right? That would be one solution.
Okay. And what if you were, so the original idea of Java EE7 was to move to the cloud. And so therefore, you need to test. So therefore, how would you be testing CDI if you're not using Archillion or something like that? How would you test? And it's probably not specific to being validation, but,
right.
But it's a general thing that...
So we got two stages, right? Most implementation that I know of actually have a SC mode, so you can use their actual proprietary API extension to bootstrap CDI from within SE and get it working and customizing your configuration to test it. I believe the plan is to get that standardized, but in CDI 2.0, so not for this version, but the version afterwards. Because I don't remember the reasons, but they were probably busy on other fronts and could not spend the right time, because it's somewhat complex idea, so you need to spend the right time on that one. Maybe one last question and then we will part. No? Yeah. All right. Well, thank you very much for being here.